5 times the first of 3 consecutive even integers is 5 more than the product of 4 and the third integer. Find the integers. So for this integer problem, the first thing we need to do is label our variables. So note we have 3 consecutive even integers. So for example, an example of 3 consecutive even integers are 2, 4, and 6, or 10, 12, and 14, even integers that follow each other, right? So the first thing we have to do is let n be our first even integer. Now, to get from any even integer to the next even integer, we add 2, right? To get from 2 to 4, we add 2. To get from 10 to 12, we add 2. So in general, if n is our first even integer, then n plus 2 would be our second even integer. And similarly, if we wanted to get to the third even integer from the first, we would add 4, right? That's how we get from 2 to 6 and from 10 to 14. So we can say that n plus 4 is our third or our last even integer. So now we've labeled our variables, and now it's time to interpret the problem. So the problem says 5 times the first of the 3 consecutive integers, so 5 times n is, which stands for equal sign, 5 more than the product of 4 and the third integer. So you take the product of 4 and the third integer and add 5, since it's 5 more. So that's how we interpret the problem, and now we just have to solve for n. So, simplifying the right side of the equation, I want to distribute this 4 using the distributive property over that sum. So you get 4n plus 16 plus 5. So 5n is equal to 4n plus 21. And then finally, I want to subtract a 4n from each side of the equation. So what we have on the left is just n, and on the right we get 21. But now notice that the problem said that we were looking for 3 consecutive even integers, and the n that we got is an odd integer. So because 21 is not an even integer, then we have to conclude that there is no solution.